Hi everyone, Shine is here. In this demonstration video, we are going to see how the upper part of the plumber block, this part number 3, can be created, and then we hopefully put all the parts together and add the standard parts as the bolt and nuts. So let's get started. In the last video, I showed you how you can utilize an image of a drawing. So we do the same technique here. That's very useful when you want to do reverse engineering. So you have a picture which has kind of dimensions on it, or so we do a sketch first. So from the tool in the sketch menu, there is sketch tools. You find the sketch picture, and what you need at this stage is a JPEG or bitmap of the picture which you want to use for measurements. So in this case, again, we have the calibration arrow. So you have to bring the beginning at the beginning of the largest dimension. The reason I said largest dimension is to minimize the error. Basically, you can do this with any dimension. So here, that is 170. Now my picture is calibrated, and from this point forward, I can do direct measuring from this picture. Of course, it has some errors in it. So let's remind ourselves, how does this shape look like? It is a upper block. It has a cylindrical face inside. Both outer sides are flat, and then these ears, they have the cylindrical faces, and then there is a cutout to allow the bolts sitting there properly. So let's remember also there is a hole which helps to oil the bearing. So we remember all these features, and the strategy that I'm going to use for drawing is I'm going to draw over this and to start that, let's finish the sketch tool, and then I need a center line, and the center line could be here. That is the axis of symmetry. Of course, I make only half of the part, and then the rest is mirrored. All right, so from this center I draw a circle. So that is pretty much it, and now I need to I remember that the cylindrical part of the journal bearing, the diameter was 42 millimeters. So therefore here I need a circle of 21, half of that diameter. So that is 21. So that is the cylindrical part of the upper. And then let's remember that this one is coming down with the two flat faces. Okay, so that means I need to make a rectangle from here perhaps to there. All right, and then a little line to bring this from here up to, I think, up to somewhere like that, where it intersects the step inside. So it has to cut this circle, right? So it's let me just make this one vertical, and then we see where it intersects. Okay, now let's zoom in, and trimming tool, we cut this at the first intersection, and like I said, you don't need the right hand half because this is going to be mirrored. But this circle I cannot trim because it doesn't have a proper cutting edge, or does it? Maybe it does. Just and this portion should go, and that has to go also. All right, so it could be that this one has a thickness. It is not so let's offset this one, or maybe I just have a look at, yeah, that has a thickness, so it means there must be a flat part at this edge here, maybe to create that what we need is something like that, and then all right, so it is ready to be mirrored. So how do we mirror? Just select the component you want to mirror. So these are the items to be mirrored, and then the mirror line is symmetry line here. All right, so if things are okay, that sketch can be used to extrude this. The extrusion is 37 mil. Let's extrude that for 37. And then we remember that these faces are cylindrical. How do I find that? How do I complete that? Make another sketch on top of this face. So here again I make a symmetry line from that center to the center, and then from middle of this center line I just make an arc. So the arc which is passing here, that is 43, very similar to the one which we estimated from the lower cap. And then convert entities, convert this one, that one, this one, and this one, that one, and this one. All right, so now to add the cylindrical faces, the sketch has to be yep, so I think that the sketch is now ready for modifying the shape. So that is the sketch I have. Finish the sketch and have this one as extrude. So reverse the direction, flip the direction, and then it's not a blind extrusion, it's up to the surface. We want that to be extended up to here. Okay, and anyone remembers the distance between the holes? The distance between the holes is 62, and 62. I make a new sketch on this face, and right, so again let's make a line of symmetry, and if I create hand free inline here, and the distance between here and there is 62 divided by 2, which is 31, and the diameter of this one is 10. So smart dimension, that has to be 10 to comply with the lower one. And now you can mirror this one, this circle to be mirrored about that line of symmetry. All right, so one more thing, we remember that in the instruction page there are two modification of that face to let the bolts sit in there correctly. So I can only make a guess. This is something like yeah, over here I need to make another circle concentric with that. I think that is good. So make that 12. And right, so this circle to be mirrored about that one. No, that is not the mirror item. The mirror line is here. So okay, so how do we use this sketch? So that is how I do it. From this sketch I go to the feature, cut extrude, and then in order to make this go both way I choose the mid plane. So I make this one a mid plane, and then yeah, one way is cutting the drill. Yeah, well, let's just do a different way. I keep this sketch as a reference, and then I make another sketch on this plane, and here in this new sketch so I make a new sketch on this plane, and then convert entities, this one, and with this sketch we do a through hole, and now we make a second sketch that to start on the same page, but this time we convert entities from this circle and this circle. This time the cut extrude is in a opposite direction. So I have to flip the direction of the extrude. Yep. Okay, that does the job. I think the last thing we need is to drill a hole here for letting the oil reaching into the journal, and that's pretty simple. Just make a sketch on this plane, and at the middle of this center line let me extract convert entities, this one, and this is a normal line, is it? Yeah, if that's a line we have to change this to the, yeah, now I think that's, you do a circle radius of 2.5, oiling nip, and yep, that sketch now can be extruded cut through. Oops, no, in opposite direction. Not this one. So the last sketch, oh, the last sketch has some leftover. This shouldn't be included, so let's modify it. So in this last sketch you don't need that part. Okay, now finish, and that sketch to be extruded cut, in flip the direction, and to make that through, well, I can have this one through the mid plane, and now that's better. It means we make the hole on both sides. Okay, so this is seems to be complete at this stage. I save that as a upper block, and with this upper block I have all the main components. So at this stage, let's make a new assembly. This is a blank assembly file, so we bring the 3 parts one by one in. So in this new assembly, the first part which I'm going to bring in is the bearing itself. So we place bearing here, and then you bring lower block, place it somewhere, and then bring the upper block, place it here, and now we want to define the relationship. So let's see which one is fixed, which one is, so this one is fixed, this one is floating, this one is floating. Right, so first thing is to make that cylindrical face mate with this cylindrical face, not this one, sorry, the one, this face, that face mate with this one, and also disapprove this face to be made with that face, approve. And the next thing is, this is an advanced mate we haven't used before. This is related to the width, so I'm gonna make the width of this one and that one align with the width of this one and that one, so that bring that right in the position. We do the same thing for width of this face and that face, with the width of this face and that face, so that brings it here. So now that is, oops, I think the last mate was not quite satisfactory. I can have this one modified, edit. So when we edit, that's this face belonging to, let's do it again. So in the second run we wanted the, okay, so let's bring this one, yep, it's better now. So I make width of this and that align with the width of this, and that. And now rotationally, what you could do is to make that one and this one parallel. Go to the standard mate, make them parallel. Yep. So the next step is to plug the bolts and nuts. So here we go to the library, and then from the toolbox you go to the adding the toolbox, and I'm choosing that from the ANSI metric bolts. Let's grab something like, let's see what we have, not self-tapping, mechanical screw, the countersink, not this one, hex head, yeah, I think that is not bad. So I'm grabbing this one, so when I grab this in, I think I have to exit the mate first. Yeah, alright. So now from here I grab this one and bring that near to this cylindrical hole, and magically it detects the diameter. So that is M10, I think. And what about the total length? The total length, just from here, the total length is 85. So make the total length, yeah, 90. There's no 85. 90 is good. Okay, and right, so the second one I put it here and then press escape. So this bolt, you can make this cylindrical face mate with that cylindrical face. Approve, and then you want this edge to be coincide with this edge. Well, they are concentric, but let's do that again. You want this face to coincide with that face here. Oops, didn't go through. Why not? Let's do that again. You want this face, and also you want this edge with this edge to be concentric, and then making this face and this face together. And finally, to add the bolts, you go back to nuts, and from here you grab these nuts to this bolt. I think you have to exit the mate first before doing that. So I grab these nuts and drop it over this one. Okay, so that is M10 again. So that is M10. Alright, and the second one you put it here and then press escape. So that this face to mate with that face. Approve, and this cylindrical with that cylindrical. Approve, and you do the same thing here. This face, approve, this face, that face, approve. And finally you want to add two more larger nuts here. I drag that one, so I have to exit the mate first before bring the part from the library. So I bring that one and try to, yeah, if I drop it here, it would detect the size, right? So this time it detected the size properly. M10, yeah. So you approve, and it lets you to bring the second one. The second one you apply it here and then press escape. And finally all you have to do is to add a mate between this one and that one. Approve, this one and that one, approve. And finally, okay, now I got my full assembly. How do I make a bill of material? That's the important part. So let's save this one. And then to make a bill of material, you either can do it in the 3D space, insert. I don't think you can do it here. You have to make a drawing first. So to make a drawing, make drawing from assembly. If you want to make a exploded view, so let's do the exploded view first. So with the exploded view, I just would have an exploded view generated. Yeah, something is not right with my exploded view, is it? So exploded view, so that is like so. Yeah, that is, the axes are not right. Okay, so I don't know why the axes are rotated. Maybe, yeah, make it, oops. Anyway, so I'm pulling this one out, done. This one, pulling that out, done. This one, bringing out, done, 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 and finally this one, we bring this out, done, okay. Now this exploded view is complete. So what I do from here, save this first, go to make drawing from assembly. Okay, now in this assembly I can drag the exploded view, put it here, and then go to the annotation, adds balloon. This one, this is a balloon, balloon. All right. And the next thing, we want to insert a bill of material. Go to insert table, bill of material, and for this part, bill of material, this is the default. You can change the default if you wish, and then that is your bill of material. Of course you can modify the columns, add whatever you want to include in your bill of material. Alright, I hope this demonstration video helped you to improve your skills, and take care. See you soon. Bye.